Okay, this might be the last problem we do. Yeah, it is. Okay, so let's go ahead and now use this in modeling a real world phenomena. So y'all have had little bouncy balls, right? Those little rubber balls, right? Basketballs can do this too. Anything that can bounce. So you have a situation here where after each bounce, the ball goes only 2/3 up from its previous height. So that means whatever height it was before is now 2/3 times that height. And then we're going to answer these questions in a minute. Well, let's go ahead and model this real quick. So here's the height. Here's where you drop the ball. Okay, it goes down, and when it bounces, it's going to go up only 2/3, and then it's going to come back down. And then when it bounces, it's going to pump back another 2/3, another 2/3, another 2/3, another 2/3, another 2/3, and then sooner or later, it's going to catch the friction of the floor and then start rolling. Okay? So this would have been the first height. This would be the second height. This would be the third height. And this would be the fourth height. And the fifth height, which is what we're asked to find. And then so forth, and so forth, and so forth. Okay, so our starting number in the sequence is 6. And now we have our explicit formula for the sequence of heights. Notice the first number in the sequence creates a 0 exponent. I'm just pausing. Okay, so we got our formula we can use. Now, formulas aren't always necessary, right? Sometimes you can just use the pattern. So we want to find the height after the fifth bounce. All right, so then if we want to use the formula, our exponent's going to be 5 minus 1. Okay, so this is what you could calculate. Now, be careful again when you calculate this, because if you want to raise this fraction to an exponent, be better to put it in parentheses. Now, I don't know what calculators you guys are going to use on your end, but if we're already on a computer, we might as well use Google. So I'm going to go ahead and type that in right here. 6, I'm going to start parentheses. I'm going to go 2/3. That really means 2 divided by 3. Okay, then I'm going to use the caret symbol, which again, that's the little rooftop symbol right above the 6. And then I can do 5 minus 1 in my head, so I'm just going to make that 4. Right? We can do a little bit in our head here. 5 minus 1 is 4. Okay, so we have Google do that, and there it is. So a little bit more in the foot. After the fifth bounce is a little bit more in the foot. All right, so this would have been the fifth bounce. So that right there would have been a little bit more in the foot. Okay, well, how many more bounces is it going to take for us to get less than a foot? Right? So or less than an inch, my bad. Okay, well, since we're dealing with feet here, Less than an inch means less than 1/12. So we want to figure out what n would be so that our explicit rule is less than 1/12. Okay, well, you can divide 1 by 12, but that basically means 0.0833. Okay, well, that could be a little tricky, right? I mean, we could guess and check. We know it's got to be more than 5. So we could try, see if 6 minus 1 would work, 7 minus 1 would work. So that is one way we could handle this. I'm going to show you something on Desmos in a moment, but if you just want to go to the original calculation, it's still there. Let's see, okay, so let's say this was 7 exponent, so 8 minus 1. So I'm going to put this as a 7, and oh, not quite. So that means it's after the 8th bounce, because remember the 7 came from 8 minus 1. So after the 8th bounce somewhere. We could do that again, put 8, put 9, put 10. That's one way of going about it. Nothing wrong with that. Okay, well, let me show you something on, no, not that Desmos. No, I guess it doesn't matter. We could do it here. So I'll send you a link in the chat in a minute. And I'll show you how we can have Desmos do this for us really quickly. So there's the link to Desmos. I'll just go ahead and close that container. Okay, so what we're going to do is we're going to set up a table. And we're going to use this rule to create the second column in the table. You might remember us doing this last semester, I think maybe once. So the rule, what we're going to use is this. And we're going to use the exact same formula since Desmos can't intuit what we mean. So go here, create a table. And so 0 would have been something if we we're doing exponential models, but we're not. We're making sequences, so we're going to start with 1, and then 2, and then after that, Desmos will just assume. Now, if we're going to do this, here it's telling us we can put the y's here, and it'll associate this with y1. But we want to make a rule here that will use the x's and create the numbers in the sequence. Okay, so remember what the rule was. We're basically going to type this in, and instead of n, we're going to put the x sub 1, because we have to work with what Desmos wants. Okay, so I'm going to put right here, we'll put 6. And so notice it automatically assume, okay, you just want that to all be 6s. It's assuming a constant rule. Okay, I'm going to open up parentheses and put the 2/3 in parentheses. So if you go 2 divided by 3, 2/3, it'll automatically assume you mean that. But if you need to do that, you can manually do that right here too. Okay, now we want to tell it an exponent. So if you want to use an exponent, you could tell it right here, or you could use the symbol, rooftop symbol. So if you go Shift 6, it'll grab the rooftop symbol, and it assumes, okay, you mean an exponent. Now this is where it's a little tricky, because this is our exponent. Okay, we want to put the variable -1. All right, so I'm going to put parentheses right here. I got to click there, so that it knows whatever I'm typing belongs in the exponent. If you don't put parentheses here, so it knows that's an exponent, but as soon as you hit minus, it doesn't put the minus in the exponent. So
Get that? Could you try again?
Yeah, Siri.
I thought.
Siri decided to have an opinion. So that's why I'm opening up parentheses uh, right here at the exponent, so that when you do the x and then 1, notice it automatically assumes the numbers in the first column, and then you go -1. Now it'll keep that -1 in the exponent. Okay, so now we've got our formula, and notice it's already calculating. So if you go ahead and hit enter, it'll jump to the next integer. Notice we're getting what we just got a little earlier. All right, so let's see. Okay, still not there, still not there, still not there. We just got there. So the 12th bounce is when we're less than an inch. So when n is 12.